faculty members, students of CUG, ladies and gentlemen. I am from the CII, Confederation of Indian Industry. Today I will be making a short presentation on a decision support system developed by CII. As you all know, the water crisis looms across large parts of the country. So a decision support system assumes importance. A decision support system which can actually, take the technical and scientific advancement and help decision makers to arrive at their decisions to undertake management of the water resources in a sustainable manner. CII has developed this unique tool, which is a an innovative and water assessment tool. This is IT driven, GIS based information system, which is capable of undertaking comprehensive water shed evaluation. The tool relies primarily on information collected from satellite sources. Apart from that, we also rely on ground information, which are fed into a decision system framework, which takes on further analysis. The tool is, computationally very efficient. Millions of pixels are analyzed, and we rely on multiple data sets. It is sophisticated and robust in nature, and it can be applied at various scales. These are the various applications of WattScan. And one of the emerging is how it can help society and industry on embarking on water management. Today I'll take you through one of the case studies of WattScan, which pertains to Aurangabad district, a drought-prone district in Maharashtra. How the application of WattScan has actually helped in improving the water resources of that area. So to start with, when we to calculate the total water requirement or the water demand of Aurangabad, we took the crop water requirement, what is the domestic water use and industrial consumption, and the water availability was calculated by using WattScan model. So what we found was that in normal years there was a deficit of 1,000 cubic meter per hectare. Whereas it increased to 3,000 cubic meter per hectare in bad rainfall years. And this bad rainfall year occurs mostly in every 3 years. And as a result, there was a huge stress on the groundwater. So this was the initial scenario when we started the study. The various, the inputs measure which goes into WattScan are reflected over here. It ranges from topography, drainage, and this input measures then comes out with the output. The output of WattScan is actually interesting. It gives you an insight into the following. Number one, what is which are the pockets within the water set which are rich in water generation and low in water generation. It is all in relative terms. Similarly, within the water set, which are the pockets which are rich in water accumulation and low in the water accumulation. And similarly, what are the losses we encounter when you try to capture water either below the surface or above the surface. Again, it is the same. The pockets, high pockets of water, high pockets of losses and low pockets of losses. Other than that, it also tries to capture what is the fluctuation happening to the upper aquifer at the ground of the groundwater. So if you look at the interplay of surface water and the groundwater, gives you a perspective on the health condition of the water set. The water set in which you are residing, is it a fresh one or a safe one, is it a stressed one or a scarce one? Once you know the health condition of the water set, then accordingly you can design strategies to improve upon and how to make the water resources more sustainable. This is something to look at, the white patches. These are the critical zones, because here the white patches are the area where the generation is low, accumulation is low, but the rate of evaporation is extremely high. So as a result, when we apply WattScan, we come up with pockets, comparatively water rich versus water scarce pocket. So it helps in designing strategies and also prioritizing investment. This also provides critical information with respect to the issues that affects the water resources in a watershed or in any geographical location. One of the unique features of WattScan is that it comes up with basket of strategies. These strategies can be low cost to low saving to high cost to high savings. Suppose if you look at the pockets which are marked in green, these are pockets which are more conducive construction of check dams, yet the generation is very high. But if you look on the right side, these are the pink, if you look at the pink pocket, the rate of evaporation is extremely high and accumulation low. So here we suggest that we should go for some other structure, namely the subsurface dikes. WaterScan can also be very much instrumental in application of the requisite technology. The pink sedates are more conducive to undertake micro irrigations. Now the pockets which are marked in blue, here we are trying to emphasize upon municipal industry interface and municipal agriculture interface. The idea behind is to put the wastewater into beneficial use. So after calculating the savings from each of these interventions, what we found, the water scenario in Aurangabad district, the new water balance has improved a lot. This demand is 5,000 cubic meter per hectare, but in normal years, a normal rainfall year, which in earlier times it used to be, the deficit was 1,000 cubic meter per hectare. Now they have 65,000 cubic meter per hectare. That is more than 50. The availability of water has increased 50% more. Similarly, in good rainfall years, now in normal rainfall years and in good rainfall years, people don't have to rely on groundwater. But initially they have to rely on groundwater. But yes, in bad rainfall year, the deficit, there is a still deficit, but earlier the deficit was 3,000 cubic meter per hectare. Now it is only 1,000 cubic meter per hectare. And this can be met through groundwaters. And this groundwater can be replenished by through the normal rainfall and the good rainfall years, and this groundwater will also stabilize over a period of time. So what we have witnessed, that WaterScan, the application of WaterScan, this district has reinvented its water trajectory by taking into by bridging the supply and demand gap, application of requisite technology, and putting wastewater into beneficial uses. On behalf of CIA, we'd like to work with all the partners who have gathered over here to address the pressing issue of water. Thank you very much.
Yeah, now the topic is open for discussion. If any queries there, they may ask them. I think one question may be permission.
I have a query, please.
This is when you apply a WaterScan, there is a cost involved into it. But yes, we can take interns from your institute who can be trained on this. Okay. And we can train them on the application of WaterScan. We're open to this, and we already have 3 interns working for Aurangabad district. Now we have a project coming for Odisha, so we can have interns from your institute who can work in the application of WaterScan. That is not an issue. That can be worked on.